Now in last class, class 4, we discussed about the different series of spectral lines in hydrogen spectrum. Now let us see the drawbacks of Bohr's theory. Shortcomings. Drawbacks of Bohr's theory, or we can call it as shortcomings. Shortcomings of Bohr's theory. First one, it is applicable only to hydrogen atom. Applicable only to hydrogen. Applicable only to hydrogen atom. That is only to single electron systems. Single electron systems. Applicable only to single electron systems. Hydrogen, He plus, Li2 plus, like that. It is applicable only to single electron systems. It failed in case of many electron systems. Many electron systems. For sodium, it was completely failed. For sodium, it is completely failed. It is applicable only to hydrogen, not to many electron systems. First one and second one. Third one, it cannot explain the fine structure. It cannot explain fine structure. It cannot explain fine structure. What is fine structure means? We know that Balmer series, N1 is equal, for Balmer series, N1 is equals to 2, N2 is equals to 3, 4. That this is N is equals to 1. This is Balmer series, no? This is Balmer series. This is observed in the visible spectrum. In Balmer series, observed in the visible spectrum. This is H alpha line, H beta line, H gamma line. If you observe these lines with a high resolution spectrometer, or we observe these lines with a high resolution spectrometer, again H alpha is split into many lines, H beta into many lines, H gamma into many lines. And so this cannot be explained. The splitting of spectral lines is called as fine structure. Splitting of spectral lines. Splitting of spectral lines. Splitting of spectral lines is called as fine structure. Splitting of spectral lines is called as fine structure. It cannot explain that fine structure. This cannot explain that fine structure. This is also a very important one. And single electron systems is very, very important one. Next, the intensity of spectral lines cannot be explained by this theory. Intensity of spectral lines. So H alpha is more intense than H beta. The first line of Balmer series is more intense than second line of Balmer series. This cannot be explained by this Bohr's model. Intensity of spectral lines cannot be explained by this model. And next one is, it failed to explain the Zeeman effect and Stark effect. Zeeman and Stark effect. It failed to explain Zeeman effect and Stark effect. Splitting of spectral line under the influence of magnetic field is called as Zeeman effect. The fine structure in case of magnetic field is called as Zeeman effect, and fine structure in case of electric field is called as Stark effect. Splitting of spectral lines in the presence of magnetic field is Zeeman effect. Splitting of spectral line in the presence of electric field is called as Stark effect. It cannot explain the Zeeman effect and Stark effects. Now, wave nature of electron cannot be explained clearly. Wave nature of electron. Wave nature of electron given by de Broglie hypothesis. So, wave nature of electron cannot be explained clearly. Cannot be explained clearly by this model. Wave nature of electron cannot be explained clearly by this model. This does not match with the, what we call the de Broglie's hypothesis. We will discuss this in the later next classes. What is de Broglie hypothesis? Now, wave nature cannot be explained clearly. Next, Heisenberg principle was violated. Heisenberg principle. Heisenberg principle was violated. What is Heisenberg principle? The product of uncertainties in position and momentum. Product of uncertainties in position and momentum is greater than or equals to H cross, or we call H cross is equals to H by 2 pi, we can write this one as delta x delta p greater than or equals to nh cross or nh by 2 pi, nh by 2 pi. So this is cannot be explained. This is violated this Heisenberg's uncertainty principle. And lastly, the electrostatic force between nucleus and electron is explained, but not electron to electron. So this cannot give clearly the electrostatic forces between electron and electron, but gives clearly about the forces between this what we call this electron and nucleus, but not between electron and electron. Now let us see what is fine structure constant. I have discussed what is fine structure. Splitting of spectral lines. Splitting of spectral lines. Splitting of spectral lines is called fine structure. So Bohr's theory failed to explain this fine structure. Later Sommerfeld theory has explained this fine structure by introducing a constant called as fine structure constant. Fine structure constant alpha is equals to E square by 2 epsilon naught CH. This is what is called as fine structure constant. E square by 2 epsilon naught CH is called as fine structure constant. The value of this one is 1 by 137. 1 by 137. E is constant, charge of electron, epsilon naught constant, C constant, H constant, velocity of light and Planck constant. If you put all this value, this one as 1 by 137. Now why I have taken this one is, it is also very important relation. See, once fine structure constant is E square by 2 epsilon naught CH. We have derived velocity of electron in the nth orbit is velocity of electron in nth orbit is derived this one as velocity V is equals to ZE square by 2 epsilon naught NH. We have derived this velocity as velocity is equals to ZE square by 2 epsilon naught NH. We have derived the expression for velocity here. Velocity of electron in the nth orbit is VZE square by 2 epsilon naught NH. Now let us say V is equals to ZE square by 2 epsilon naught NH into C by C. Let us see into C by C. No problem. Therefore this becomes ZE square by 2 epsilon naught C into C. This becomes CE square take this is for hydrogen or leave it, no problem. ZC E square by 2 epsilon naught CH by N. We can write this like this now. ZC have taken like this. ZC E square 2 epsilon naught CH into N. Now what is E square by 2 epsilon naught CH here? E square by 2 epsilon CH is alpha. So we can write this one as implies V is equals to, therefore ZC by N into alpha. V is equals to ZC by N into alpha. So relation between velocity and fine structure constant. Velocity and fine structure relation is V is equal to ZC alpha by N. But alpha is equals to 1 by 137. Therefore V is equals to ZC by N into 1 by 137. Now what is the unit of alpha now? What is the unit of alpha? Here Z is the atomic number, no unit. C is the velocity of light. And N is the principal quantum number, no unit. Therefore Z having no units, N having no unit. Therefore it is velocity. Therefore this should have the unit of velocity only. Already C is having the unit of velocity. Therefore alpha is having no units. Alpha having no units. Alpha have no units. Why? Because here Z and N are having no units. If this should be velocity, that should be velocity. We can equate kilometers to kilometers and liters to liters only. But we cannot equate liters to Ks or kgs. Therefore, V is equals to ZC by N means Z no unit, N no unit. C is the velocity unit, V is the velocity unit. Therefore, alpha should have no unit. Therefore, alpha is time. If you put the values here, you can put it also dimensionally. So, this is something about fine structure constant, very important one. So alpha and V relations we have seen now. So what is emission, transition and number of lines? Emission, transition and number of possible lines. Number of possible spectral lines. Number of possible spectral lines. So emission spectra is possible when electron makes transition from all higher levels to the or any level to the any level, not higher level, any level to so any level. So emission transition may takes place. So these are all emission transitions. These are all emission transitions only. These are all emission transitions. Therefore, emission transitions takes place when electron jumps from higher energy level of quantum number n2 to lower energy level of quantum number n1. These are all quantum numbers or energy level numbers, k elementals. Therefore, emission spectrum is possible or emission line is possible, emission transition is possible when electron makes or jumps from higher levels to the lower level. If n2 is the quantum number in the higher level and n1 is the quantum number in n1 level, the number of emission lines or spectral lines. Number of emission lines or spectral lines are n2 minus n1 into n2 minus n1 plus 1 by 2. n2 minus n1 into n2 minus n1 plus 1 by 2 are the number of emission lines or number of spectral lines. Number of spectral lines or number of emission lines observed when the electron jumps from n2 level to n1 level or n2 minus n1 into n2 minus n1 plus 1 by 2. For example, let us say n2, if it jumps to ground level, if electron jumps from higher level n2 is equals to n to ground level n2 is equals to n1 is equals to 1. Ground level means n1 is equals to 1. Ground level means n1 is equals to 1. The number of lines are n2 is equals to n minus ground level is 1 into n2 is equals to n minus n1 is 1 plus 1 by 2. This becomes, this gets cancelled, n into n minus 1 by 2. This is the number of spectral lines emitted when electron jumps from higher level to ground level. When it jumps from higher level to ground level, the number of lines observed are n into n minus 1 by 2. n into n minus 1 by 2. For example, electron jumps from n is equals to 4 level to ground level. Therefore, we can take n2 is equals to 4, n1 is equals to 1. n2 is equals to 4 level to ground level. Then what happens? How many lines are observed here? Number of lines observed are, the number of lines, how many lines? Number of lines observed are, so n is equals to 4. 4 into n minus 1, n 10 minus 1, 4 minus 1 by 2, that is equals to 4 into 3 by 2, that is equals to 6 lines are observed. How these 6 lines? So, take the lines here. So, n is equals to 1, 2, 3, 4. It jumps from higher level to 4 nunchi 2. Therefore, possible states are 1, 2, 3, 1, 2, and only one. How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 are the possible transitions. Therefore, number of possible transitions are 6 lines are observed. Therefore, here you can say like this. This is justification for this one. If electron jumps from n is equals to 4 level to n is equal to 1 level, number of possible spectral lines observed are 4 to 1 means 4 into ground level. Therefore, n2 is equals to n, n2 is equals to taken as 4, n1 is equals to 1. Therefore, we get n is equals to 4. 4 into 4 minus 1 by 2. 2 into 3, that is equals to 6 lines. How we can get 6 lines? N is equals to 1, 2, 3, 4 lines. 4. Now 4 energy levels. Therefore, n is equals to 1 ground level, 2, 3, 4 levels. It jumps from higher level 4. Therefore, what are the possible transitions? 4 to 1, 3 to 1, 2 to 1, and 3 to 2, and 4 to 2, and 4 to 3 are the only possible energy level. Therefore, total number of lines are 6 only. We get here only 6 lines. Similarly, number of absorption lines from ground state to excited state, nth excited state. Number of absorption lines. Number of absorption lines from ground state to excited state are n minus 1. Number of absorption lines. Number of absorption lines from ground state to excited state are n minus 1 only. This is the something about Bohr's theory.